Unity itself as a game engine is written in C++, and also we can build our games in the high performance but a little bit more complex C++ language. But Unity allows us to write our code in a much more welcoming C# language. So with that in mind, ladies and gentlemen, this is your game dev speaking, and today we'll make your first game, or at least part of it. This is a Getting Started with Unity series part 2, but don't worry if you didn't watch part 1, we just talked about Unity and its basics, and today we'll make and program the game. Okay, so first off we have this blank new and untouched scene. So before filling the scene with creativity, entirely optional, but we will delete some stuff to clean the assets folder, which is our primary folder. So just delete these two things, which are the new input system and URP volume. Don't worry, we will go through this later, as well as the extra scene folder that we have inside settings. Now just to show, we can right click here in the project window and show in Explorer, and you can see the files and folders here. By the way, Unity creates .meta files for each folder and file in your project's asset window. It basically tells Unity how to prepare the asset in the project. Assets refer to files, folders, music, models, and also images. So now that we have a clean and clear canvas, let's start painting. So let's right click on our hierarchy, and you can see a bunch of options here. We will just go to the 2D object, sprites. By the way, sprites just refer to images, so don't get confused there. And we can for now just select the square one, and there we go. Now we have a square in our scene. By the way, you can rename everything in the hierarchy. You can either do that in the hierarchy, or you can do the same thing from the inspector panel as well. Like I said, we're gonna spend a lot of time in the inspector panel. We can change it to ground, we can change it to player. Like for now, we're just gonna say it's called ground. There we go. Now we have a game object. By the way, every single thing in your scene is referred to as a game object, just so you know that. And every single thing in your scene will have a transform component to it, because just to know where it is. And yeah, there we go. Now we have an image in our scene, or it's called sprite for the timing. Let's just call them sprite for now. By the way, you can resize every single window in your editor, and you can add and remove windows as well, but we're gonna go through that later. For now, in the game view, you can see we have a sprite, we have a square. So let's position it somewhere down there so that it appears as a ground. So as you can see in the transform, you can change the position as well from the inspector, and you can of course move it to change the position as well, but now we have to scale it. So now we can use these tools here, these GUI tools that we have. So we are going to use the rect transform tool, which basically allows us to change the scale of the object that we have in our scene. So we can just pull this here, and if we use Alt and do the same thing, you can see I can do the same thing to both the sides. What just happened there was that I also pressed Shift at the same time, so it expanded in all directions. So now that we have a ground, you can see we have a sprite render component to our sprite. Well, that's the thing that actually makes the sprite. Otherwise, it's just a game object. So we can also just go to here and go to the debug option, and you can see there are a bunch more stuff here. But don't push your mind. We're just gonna stay at the normal view for now. And yeah, this is the sprite render component. You can of course change everything in here, although we are just gonna keep it as it is. And yeah, these are the properties of your sprite renderer, which you can change accordingly. So of course the primary property in here is of course the color, so you can change that. We're gonna make it a little bit green, and yeah, just like that we have a ground. By the way, as for the background, you can see in the blue background, you can actually go to your main camera, go to environment, and as you can see in the background, it says it's blue. So yeah, you can change that, although we are gonna keep the blue for now, because well, we are not exactly gonna use this background as our primary background. Let's head back to the scene, and now we can do stuff to. Now we're gonna add more objects. So this time let's add let's add this, a hexagon. And as you can see, it also has a sprite render, so you can actually go to the sprite, and as I said, you can change everything in here. So let's change the sprite in here. You can see there are a bunch of sprites. Again, sprites just refer to images, okay? Don't get like overwhelmed with it. It's just a photo, okay? It's just a JPEG or PNG, and as you can see, it's literally just a JPEG. Sorry, it's a PNG in here, and you can see in the show in Explorer, it's just a PNG file. nothing more, nothing less than that. And in fact, we can even just use our computer's image viewer to see them. This is the hexagon file, hexagon image that we currently have in our scene. So don't get overwhelmed, it's just a photo. Alright, so now that we have a basic understanding of sprites and shapes, I think it'll be a lot better if we add some components to it so that it interacts with the world. So we have this sprite render to it. We are gonna add one more component, and that component will be in the physics 2D. Remember, there are physics and physics 2D box, and we can add the box collider, but then it will just add a square shape collider. But we have a hexagon, so we're gonna add a polygon collider. And just like that, we have one more component to our game object. And you can actually see there is a very small green line. You can actually turn off sprite render, and we can see it perfectly now. Remember, colliders are a very important tools because, well, they are the ones that allows our game objects to interact with the world. And we can actually edit the colliders. That's right, yeah. It's just a polygon collider. You can edit it however you want. So yeah, for now, let's just close this, and yeah, now we have a collider. Now if we just click on the play button, you can see nothing actually happens. The reason being, well, we didn't really tell our stuff to do anything. Duh. So let's add one more component to this called physics 2D, and it's called rigid body 2D. This is probably one of the most one of the best components that we have inside Unity. It basically turns any object in our scene into a physics body. So yeah, now let's play, and you can see it falls right through the ground because, well, again, as I said, you need a collider on the thing to, well, actually, interact with the stuff, and we don't have a collider on the ground. So let's add component physics 2D, and since it's a box, we don't need a polygon collider. We can just use a box collider here, and there we go. Now we have a box collider on our ground. And now if we click on play, you can see it actually does interact. Our ground stops our hexagon collider from going through the ground. Pretty cool. If I just push this up, you can see it gets stopped by the ground, and I can imbalance it, and yeah, there we go. The gravity does impact our hexagon. Now that's good, but we can add more of these. So we can just put this here a bit more. By the way, I'm using Ctrl D to duplicate these things. Now if we play, you can see some good physics interaction. And you can of course play with these a little bit. But still, like, these all are good, but currently we are not really doing anything in the game. So let's do that. So all of this physics interaction is pretty good, but for now we can just delete all of these hexagons and actually add another square to our scene. So right click, 2D object, sprites, square. And there we go, now we have a square, and we can now rename this to player. Nice. So now we have one square and another square, but again, remember, to do some interaction we're gonna need colliders and rigid bodies. So let's go to physics, box collider, and physics, rigid body. So that works well. Now we have the components that are required to, well, interact with the world, but now we're actually going to do some programming. So let's right click and create a new folder in our assets folder, call it scripts. Open it up, go to create, and a mono behavior script. Let's name it to something like player movement. And yeah, you can on the right side, you can actually see in the inspector panel the script, what this script currently is. So we can actually just right click and show in Explorer, and you can see that we have our script and as well as its meta file. So for now, how exactly do we open this? We of course need to install the Visual Studio Code, which is like the which is like the industry standard for, well, let's just say programming. And once you have that installed, you can go to edit, preferences, external tools, and you can see in the external script editor the Visual Studio Code. You will need to browse it, or you might just see it here. And yeah, you can now just close it, and we can double click on our script to open it. So here is our player movement script. As you can see, it's called public class player movement, which is of course the name of our script. Remember, this can be different, and it have two methods, void start and void update. Start is called once at the starting of your game, and update is called every single time, every frame. So say our game has 60 FPS, so the update function will be called 60 times per second. Anyway, let's start off, like enough talking, let's start off programming. So first thing that what we want to do is, well, here's our player, and we just kind of want it to move like left and right. Now we have seen what rigid body 2D can do. So rigid body 2D is capable of well, moving your thing in the game. So currently it just drops down, but we can do more to it. So what we are gonna do is get rigid bodies component and make it do stuff. And again, this is gonna take some time to understand, but just bear with me right now. So what we basically have done, we can just Control S to save this and go back to Unity, and we can just drag and drop our script to here. And guess what, you can actually just use add component here. Just type in here PLAYER player movements, and there it is. And as you can see, there is an RB, and it requires a component, so like this here. So we can just drag and drop our rigid body here. Okay, what we basically want from rigid body is to increase its velocity towards left or increase its velocity towards right, depending upon our keyboard input, right? So that our player can go left or right. First of all, we're gonna need some input from the player, but before we do that, I just wanna show you how we're gonna do it. So first, let's just create a float. Again, float is just a variable. Float speed. What this will do is, well, our rigid body is going to increase its speed depending upon this value. So what we are going to do is RB dot, and as you can see, there are a bunch of different well, let's just say components that we can access from rigid body. So we're gonna use the linear velocity. Again, you're gonna have to sort of learn what the components are, but again, the IDE or the developing environment or your code editor will make your job 1,000 times easy. Alright, so the linear velocity, we can just equal to speed, right? Because we want it to be speed, and semicolon to end the sentence. And remember, update is called once per frame. Well, but as you can see in here, it says right, and you can see the issue here. By the way, if we just Control S to save this and go back to Unity, you can see in the console the error. The error is the same thing, like cannot implicitly convert float to Unity engine.vector2, and here also it says the same thing. So what's the issue? Well, linear velocity, this value that we want to change, expects us to give a vector2. Vector2 is basically a 2-value, let's just say it's a 2-value integer. Alright, that's the best way to know it. So what we wanted to do is, well, convert this from float to vector2, and there we go. It's as easy as that. For now, we'll just Control S to save this and head back to Unity. Now remember, x-axis controls x-axis and y-axis controls for y-axis. Just keep that in mind. And even though you can see we have a z-axis, but in 2D mode, those things don't really matter because, well, it's a 2D game. So for now, let's just play and see what happens. Okay, here we have the brick, and we can sort of increase the speed, and as you can see, the speed of that thing increases, and we can switch to 0. We can change the speeds, and so yeah, in a nutshell it works. So for now, we can see that yeah, our, well, oh, by the way, one more thing. So as you can see, our player is currently falling down, right? Still in the game view, it's nothing. So as I said before, keep this in mind. The game will still continue to play even after you are like outside the camera mounts. So currently we are changing the value from the inspector panel. We want to do it from keyboard input. So how exactly are we gonna do it? So first of all, let me just remove these two things. Okay. First off, we are gonna need input from our keyboard. So let's create a public float input. Okay, as easy as that. And again, we're gonna need input on all the frames, so we're gonna use update. So input is equal to, what this line does is basically get the input from Unity itself. So you can actually go to here, edit, project settings, and into input manager, and you can see in here in the axes horizontal, you'll see the name of the axis, and you can see it's negative button left and right. That means your keyboards left and right, and also alternative negative button A and D. So it basically gives you the input from your keyboard. Okay, now that we have an input value, and you can actually just Control S to save this and open this in Unity, and you will see the input. For now, we simply need to multiply the rigid body's linear velocity with this value. So let's do it. RB dot linear velocity is equal to input. And as you can see, the same problem arises again, because input is just a float, and rigid body linear velocity expects a vector 2 from us. So here's what we're gonna do. We're gonna say equal to a new vector 2, and this is where we're gonna specify it. Yes, you don't need to always specify these variables in here. You can specify them here as well. So new vector 2, what are we gonna use? We're gonna use the input value, and then again it asks for another float. So for now, we can use 0 in here, but I think it would be a lot better if we just use linear velocity dot y. So what this line of code does, we're gonna change the rigid body's linear velocity to an input that we provide, which is from our keyboard, and the rigid body's linear velocity on the y-axis remains the same as it is. And for now, we can also just say a speed value, so that we can actually control how much the input value will simply change. And we can just Control S and go back to Unity. So now we have, as you can see in editor, we have two variables, and for now we can just play it. And if I press D button, you can see it goes to 1, it goes to -1 on A, and the same thing goes for keyboards as well. Let's increase the speed to 3, I guess 3 would be good. And if I press the right button, you can see we move left and right. So yeah, it works pretty well. Now I think it's time to add some jumping to the game, because without jumping, a platformer just isn't a platformer. So we can just double slash to make a statement like we have in here, and this is just so that we know what part of code does what. It's just for easier understanding. We can just say jump in here, and now here's the thing, we can just add some value in here, because again, just like the speed, we are gonna need a way to know how much our player will jump. So this is actually pretty easy. We're gonna do the same thing. We are gonna just RB dot linear velocity is equal to new vector 2, and this time we won't change the x-axis, so we'll just say RB dot linear velocity dot x. Remember, the first value need to be on the x-axis, comma, jump force, and then a semicolon to end this. And yeah, that is actually it. You can just head back to Unity. Set this to, I don't know, like 6 would be good. Play, and yeah, it goes up, because we need to get some input from the keyboard. So let's say if input dot get key down equal dot space, then the linear velocity will be changed to jump force. Control S and head back to Unity. Keep the stuff as it is, and let's play. It goes to the left, it goes to the right. If we press space, yes, it jumps. Pretty cool. So, and just like that, congratulations, you have just made your your first platformer. Okay, now of course the thing looks very bland right now, and by the way, we just found the first problem that we all have is that if we press space and then keep on pressing space, you can see it keeps going up. We don't want that. We want the player to jump only when it's on the ground. So first let me just change the speed to 4 and head back to Unity. Now, how exactly can we know if the player is actually on the ground? There are a couple of different ways. So basically we need a condition, like whether we are not on the ground or, well, if we are on the ground, it should be true, and then we'll be able to jump. For conditions like true or false, we use booleans. So bool is grounded. But now, how exactly do we specify if we are grounded or not? For that, we can use physics. Is grounded is equal to physics 2D, because again we are doing stuff in 2D. Dot overlap circle all. What this does is basically it returns whether. So what does overlap circle all returns? It basically, as you can see, it returns a number of colliders. Again, remember, colliders have these things, the collider 2D, and it doesn't specify the type of collider. Like any collider which is under this circle, this like consider this an imaginary circle. We're gonna provide some radius to it. So any collider that falls under that circle, it will return. So we don't want that. We need to know whether there's even if a single collider in that area. So we can just use physics.overlap circle, and it doesn't return a number of colliders. It just returns a collider. Okay. So anyway, as you can see in its in its function, we need to specify quite a few things. First is of course the vector 2 point, which is basically the center of the circle that I was talking about. So the center of the circle for now can be transform.position, which is basically our character. So its center. This part will be the center point of the circle. Consider it an imaginary circle. Don't worry, we will draw the circle right for now as well. Comma. Now we need some radius. So again, the radius can be specified here. And hold on, let me just make this public. And we can just say public dot radius, and yeah. And there we go. So now if any collider falls under this radius, it will return true, or else it will just simply return false. But now, well, there is a problem, because if we go in here and if we draw a circle in here, it will always remain true, because, well, our player's collider will always be in here. So Unity actually have a really great system which are called layers, and you can see in here the layer that this object is in, and every single game object that's in here will have a layer. So and as you can see, it gives us 5 like default layers. So we can add a new layer to it, and let's just call this layer as ground. And now we can just specify in here the layer that we wanted. So again, we're gonna have to go to here, and the way how we determine these layers are using layer mask, ground mask. Again, the naming can be anything, and here we can just say Control V. There we go. So what this is grounded will do is basically, if a circle will be drawn around our square, and Oh, as for the circle, we currently can't see where the circle is. So Unity again have a really cool way. It's called on draw gizmos. So what this does is basically a function that allows us to see inside the editor. Remember, this won't be visible in the game view. This will only be visible for us in the editor. And we can just say gizmos dot draw via sphere for now, and here we can just say the same thing, transform dot position, which of course takes the center, and then it takes our radius, and we can just column this out. So currently, and now again we're gonna need to say in here as well, but we're gonna do that later. So let's save the thing and head back to Unity. In the layer, we need to remember I've selected the ground object, which is this. Set this to the ground layer. Now that we have that, in the player section you can see it says a ground mask, and we can just say ground. There we go. And guess what? If we just simply increase the radius, you can see a circle gets appeared, and it won't be visible inside the game view. It's just for us to see. So let's click on the play button and see if its grounded variable changes. You can see it says it's grounded, and if we jump, you can see it gets disabled. You can see it gets set to false. But again, as you can see, it doesn't really matter because we can still just jump. Because for that to happen, we need to change in here. It doesn't just check if we are pressing the spacebar. It also checks if VR is grounded, and we can decrease the radius a little bit so that it just checks when we are actually on the ground, and we can just click on play. And yeah, now even though I'm pressing the spacebar, I can't jump unless we are on the ground. And so yeah, that would be just about it. That's all for now. We'll continue the next part. See ya. Peace out.